Okay, so this is similar to the board problem that I did during the lecture. And this problem involves the integrated trick. So here the statement of the problem is that an urn contains 17 white and 23 black balls. Total of 40 balls. And so choose to pick 10 balls at random without replacement. And X is the number. So we want to find the expected number of white balls. X is the of white balls. That in the last lecture, I did this problem, which was look at this one. So there are 8 birds sitting in a row, and you want to find the number of birds, expected number of birds who are not who are seen by at least one of the neighbors. And the main point was that it is difficult to find the probability mass function of this random variable. So instead, what you do, you use something called integrated trick, and there you define a class of random variables which are taking values 1 and 0, and you count a bird if it is seen by its neighbors. You don't count it if it's not seen by its neighbor. So the same logic is going to be this. The first one is you want to write this as x equal to xi, I is equal to 1 to 10. Now, how should we define xi? Okay, just to call the board problem, xi should be defined as. By the way, what is this? Where is this 10 coming from? 10 is same as the number of balls that you picked, right? So ideally, you should define xi as 1 if so define xi equal to 1 if the ith ball is white. Okay. Otherwise, we will define it as 0. Okay. And in that case, if I use the expectation formula, so expectation of x is going to be summation expectation of xi. Okay. Once again, from the last, and that was the main point of this integrated trick, that expectation of x plus y is expectation of x plus y. And this is always true regardless whether x and y are independent or not. In fact, in the board problem, the random variables were not independent, but still you can use the Okay, so expectation of xi is going to be xi takes values 1 and 0, so this is 1 times probability xi equal to 1 plus 0 times probability xi is equal to 0, which is probability xi equal to 1. Okay, so essentially we want to find probability xi equal to 1. That is, if you write in words, the probability that the that the ith ith or ith pitfall. So how do you find the probability that the ith pitfall So picking off balls from an arm is essentially like rearranging the items in that arm. Okay. So let me write this down. Okay. Finding this probability, finding this probability that okay, problem 18 in chapter 3. And there the problem was problem was 5 boys and 10 girls are rearranged or arranged in a random order. The probability that the ith location, told that there is a boy at the ith location is 5 over 15, and this items from an arm is equivalent to rearranging arranging them in a random order. So in that sense, if you're picking up 10 balls from an arm, essentially that is like rearranging for 40 balls in a random order. And you're asking what is the probability that the ith location is a white ball. That probability is going to be simply 17 over 40. Okay. And therefore, the expectation of x, so the expectation of x here is going to be 10 times, and this is true for all I. Okay, so this is true for all I. So expectation of x is going to be 10 times 17 over 40. That is 17 over 4. Okay. Any question about this part A?
Can you please explain this one?
Which one?
Can you this part which you wrote? How it came 5 by 17 by 40?
Okay. So the problem was you arrange 5 boys and 10 girls in random order. And what is the probability there is a boy at the ith location? The probability was calculated in the following way. It was like there are 15 factorial ways to arrange all the people, and then you like at ith location you put a boy, and rest of 14 people so ith location you put a boy which can be done in 5 ways, and other 14 location you just put in a random order, which is 14 factorial. This is 5 over 14. In 5 over 14. The same logic was can be applied here. So here you are like arranging 40 balls in a random order, which can be done in 40 factorial way. And then at the ith location, you could put a white ball, which in 17 ways. So there are 17 white balls, put one of them there. And other 39 locations, you just do any is equivalent to like rearranging them in a random order. Like if you're so you're like picking off items there and you're putting it aside, and you can talk of like which one is the first one, second one, so third one, and so on. Essentially, it's like rearranging them in a way. So which is being used here. And all of this was actually explained in previous tutorials. Like, so for example, this was yeah. Yeah, sure. So I said taking of items without replacement from a bin of n items is going to arrange them in at random. This was done last week's tutorial. So that's how you get the 740. And there's the second method it's asking you to do. The second method is that you write this x as summation of yi is equal to 1 to 17. Okay. This 17 resembles, so this 17 white box. Okay. So we need to somehow make the connections here. So here is the idea. So you write yi, okay, the ith random variable yi. So by the way, first of all, what you need to do is so you mark all the 17 white balls by numbers, so 1 up to 17. And then you define the random variable yi as 1 so we define the random variable y is equal to 1 if the ball marked as I is okay. So you are picking up 10 balls without replacement, and if the ball which is marked as I is picked up by any of those 10 trials, we call that the event yi had happened. Okay, and otherwise we will say it is 0. Okay. Now you notice that if you define this way, then x is the total number of, one second, we remind you, x was the total number of white balls. So this total number of white balls can as a summation of yi is equal to 1 to 17, because here the counting technology is this. You already marked the balls by 1 up to 17, and you now are picking up balls one at random and without replacement. And once you see the ball which is marked as I is up, you say that y is equal to 1. So for example, y3 is going to be 1 if the ball which is marked as a 3 is the trials, if you can count how many total white balls are picked up. And that's what I was saying, that you can write total number of white balls which have been picked up can be written as summation yi, I is equal to 1 to 17. Okay. And proceeding as above, so this expectation of x, right? So expectation of x is going to be expectation of x is summation expectation of y is equal to 1 to 7, and expectation of yi again by the previous logic. These are indicator variables. So expectation of yi is simply probability y is equal to 1. Probability yi is equal to what is, if you write it in words, is that probability that which is as I is picked up by any 10 tries. Um, so what is the probability that the ball which is marked as I is picked up by any of the 10 trials? Okay, the way to do that, so here's the idea. So here's the ball which is marked I. Okay. And how many ways you can pick that ball, pick 10 balls such that the ball which is marked as I is included. Okay, so first of all, out of 40 balls, you are picking 10 balls. The total number of so you can give that ball which is marked as I separate, and essentially you have to pick 9 balls out of these 39 balls. Okay, so you pick this ball which is marked as I. So this one ball plus 9 ball is simply 10 ball. This is the idea. Okay, so you pick that ball I, and then you pick any rest 9 balls out of 39. Okay, so it's going to be 39. Choose 9. If you simplify this is going to be let me see. So 39 factorial divided by 39 factorial times 10 factorial, 30 factorial over 40 factorial. So if you do the cancellations, it's going to be 10 over 40. Ten over 40, which is 17 over 4. Obviously, this is the same as the previously obtained answer. Okay. So you can ask me if you have any question about the whole problem so far, and let me see what was the next requested problem. Okay, so the next requested problem is problem 17 by 5. So problem 17, let me start that. So what is this problem 7? Square times r. Okay. So let me write this down. And it is given that I and R are independent random variables. Okay, good. So since I and R are since I and R are independent random variables, um, the PDF of W PDFs PDFs of I square and R and PDF of R. And we already know the PDF of R it's given, so we already know the PDF of R. We also know the PDF of I. We need to figure out, we need to find a PDF of I square. And once we find the PDF of I square, we can take the product, we get the PDF of W. Okay. So finding the PDF of I square. How do you find PDF of I square? All right. First, let's find the PDF. Of CDF to get the PDF. So first, let's find the CDF of I square. How do you find CDF? There is the So by the way, the PDF of I is given as PDF of I is given by Fi x, which is 1 minus x, 0 less x less than equal to 1. Okay. Now, how do you find CDF of I square? Okay, that's very simple. So we have let's call this f of I square t, which is by definition probability of I square so probability I square less than t is going to be probability negative square root of t less than equal to I less than equal to square root of t, which is probability 0 less than equal to I less than equal to t less than equal to square root of t. This is because if you look at the spectrum, the PDF is valid from 0 only, so we can discard the negative part. Okay, and this part is simply integration 0 to square root of t, integration of the PDF, which is 6x 1 minus x dx. Okay, great. And then the PDF of I square. Okay, so PDF of I square can be given by this little f I square t. That is the derivative of the CDF. So ddt of f I square t. So if you take the differences, this is high school differences, so 6 square root of t, 1 minus square root of t, and differentiation of square root of t, which is 1 over 2 square root of t. So eventually, this is 3, 1 minus square root of t for 0 less than equal to was already given in the problem, which was if r x was 2x, when 0 less than equal to x less than equal to 1. So that would imply the PDF of W, and it is given that W equal to I square times R. So PDF of excuse me, PDF of W is going to be PDF of W is going to be the product of those two PDFs. So let's add those, like FWX. That's going to be 3, 1 minus square root of x and times 2x. So if you write this, it's going to be 6x, 1 minus square root of x, and when equal to x less than equal to 1. Okay. Alright, so that's the end of the problem. Problem number 17. The PDF of W is you can ask. Let me see the next request problem. The next request problem is 33 is done. 27. 17 is done. 20, 24, 27. Oh, 27. Let's see what is there in 27. Okay. Um, so 27 says that the PDF of the PDF of a random variable is given by so PDF one and zero otherwise. Okay, and it's also given that so this is given, and also given that expectation of x is equal to 3/5, and you want to find a and b. Okay. So find a b. How do you do that? This is simple like linear equation solution problem. So let's write down the solution. So first of all, since this is a PDF, right? Therefore, the integration must be equal to 1, and that will give you one equation of a and b. So integration of this PDF 0 to 1. The range is from range of the PDF means. So 0 to 1 a plus bx square dx. Okay, so that integration must be equal to 1, which would imply that so integration of that is going to be a plus b over 3. So a plus is equal to 1. Okay, and it is given that expectation x is 3/5. So 3/5 is equal to integration dx, which is a over 2 plus b over 4. So a over 2 plus b over 4 equal to 3/5. And from there, I can actually write, let me do one adjustment here. So 6 over 5 is equal to a plus b over 2. this is equation 2, and that is equation 1. So a plus b over 3 is equal to 1. A plus b over 2 is equal to 6 over 5. From there, you can figure out the value of a and b very simply. So if you figure out the value of a and is going to be, so b is 6 over 5. I plotted that in 1, you get 2/5, which is going to be 3/5. That's the answer. All right. Okay. What's the next problem? So 27 done, 33 done, 17 done, and then number 20. Okay. So the next one is problem number 20. What is this problem about? So that x and y are independent if and only if this happens. Okay. All right. So we know that x and y are independent. Okay, x and y are independent if in case of discretes, the PMF case, that excuse me, the joint probability of fxy is the product of know that the conditional probability mass function, which is p x given y, x given y, as the joint PMF xy divided by the marginal PMF p y. Okay. Now, if x and y are independent, so if x and y are independent, then this will be so px. This product is going to be p x x p y y over p y y. Okay. This is if it imply that this is equal to simply p x. Okay, this is what we want to prove, that if x and y are independent, then this conditional PMF is this. And conversely, this conditional PMF, Px given y, x given y is equal to Pxx. We want to show that they're independent. Okay, so what happens there? If this is the case, then the joint PM xy is anyway going to be from this equation is okay. Now, if this is true, from this, you would get that Px given y is simply Px. So you would get just Px x Py y. Okay. So eventually, what you get is the joint PMF is same as the product of the margins. Okay, and this should imply that x and y are independent. Okay. So that was problem 20. Problem 20. Okay. Next problem. 17 done, 20 done. So very easy. The PDF is given by, so the PDF is given by fx x, that is x square x to the power negative ax, and when x is not negative. Okay, and you want to compute expectation of x. Okay, so first thing that you need to do is figure out a. Dx. And that integration has to be equal to 1. So when you do the integration here, and if you do a substitution, say like ax is equal to u, then you would see that this will simply become u e to the power negative u du. 0 to infinity. And this is always equal to 1. If you do the integration by parts, this is always going to be equal to 1. So, okay, the integration of this is always 1. And no matter what the value of a is, okay, good, that's good. And so this is true for all a. Okay, this is for all a. We have this integration 1. Okay, now the expectation of x The expectation of x is going to be integration of x square e to the power negative ax dx, and that is going to be so if you do substitution, that's going to be 1 over a 0 to infinity u square u to the u d. Okay. Standard substitution, I am taking u is equal to ax. Okay. So finally, this is going to be 1 over a. This is a gamma function. This is gamma 3. And a gamma 3 is 2 factor, which is 2. So it is 2 over a. Okay, is there any other problem? Okay, so I am almost out of time, and I think I have answered the most sought after problems. And now what you do is the usual stuff. So you go to the assignment tab, and the quiz now. So go to the assignment tab, and there is a quiz, which is quiz 4. So start taking the quiz, and you have 15 minutes to do that.